how do we find the action and reaction pairs? Well, it's pretty easy. If you can remember those sentences, all we're going to do is switch the action, the agent and the receiver, and then change the direction. So if you remember what those sentences looked like, then this will be pretty easy for you. So here's the fill-in-the-blank sentence. We're just going to kind of fill it in. So it started with a force from the agent, pushes or pulls the receiver in some direction, okay? And then we can kind of edit that sentence to make it make more sense when we read it. And so we're going to do an example where we actually are going to switch the agent and receiver, and we're gonna do the opposite direction. But I'm gonna kind of edit this. I'm going to zoom in. Okay, so we're going to take, when we do this, we're going to take our agent and our receiver, and we're going to switch them just like that. Okay, and then we're going to take our direction and we're going to make it go in the opposite direction. And that is how we're going to make our action turn into our reaction. So we're going to do an example. We're going to take the fact that you have weight when you're on Earth because of gravity. This is a really fun one, okay? Well, it's fun for me. I don't know. You might not think it's so fun, but that's okay. Okay, so the action statement for this is going to be the fact that Earth is pulling on you with gravity. So we're going to start out with the gravity force from Earth. It pulls you... Okay, I scribbled out the, okay. It pulls you down because that didn't make sense there. The you, yeah. You could put the person, okay, if you don't want to put you there. But gravity from Earth pulls you down. That is our action statement, okay, our action statement. That's our action statement because that's what we're starting with, okay. And so the reaction to that, what we're going to do is we're going to switch the agent and the receiver. So we're going to take Earth and you, and we're going to put it in the opposite places. So there's Earth and you. Okay. See how all we did was switch those. And now we're going to take, well, we're not going to change the poles because it's still pulling. Okay. We don't change that. If it pushes, it stays pushes. If it pulls, it stays pulls. Don't switch that at all. That stays the same. And now we have to make the direction opposite. Direction is now up. Instead of down, it's up. And then in this one, it's still gravity. Gravity stays the same force. Sometimes the force will change. Like usually the opposite of a normal force is an applied force. Tension is often still tension. So you might have to think about what kind of force is it now that it's the reaction. So now the reaction force, if gravity from Earth is pulling you down, the reaction to that is that gravity from you is pulling Earth up. And maybe now your mind is going, wait, what? Gravity from me is pulling Earth up? And it's true. It's not a very big force because, in the grand scheme of things, you're quite small in comparison. Well, actually, you're pulling up with the same amount of force, right? So if Earth is pulling you down with like 600 newtons, you're pulling Earth up with 600 newtons. Earth is just really big, so Earth doesn't notice you pulling up on it, okay? And I'm pulling on you with a gravitational force, and you're pulling on me with a gravitational force. We just don't notice that either because Earth is really big, okay? Those forces are much bigger, and our forces are really tiny instead. But that's an actual reaction force that's happening right now.